Jai Hind to all of you. My today's topic is image processing KCS 062. I am Rajeev Singh from Ajay Kumar Garg Engineering College, Department of Computer Science and Engineering. Today I will discuss about the morphological image processing. Morphological image processing is basically used to change the distorted images, or you can say you use to enhance the distorted or destroyed images. So before entering into the morphological image processing, we'll study some basic part of the image processing. In the basic part, the first is what is the image. We already have discussed in our previous lectures what is image. Image is nothing but the combination of pixels. It means we can say that image is created by number of pixels. So now what is pixels? Pixel is nothing but the smallest unit which will store information about the pixel. Or we can say pixel is nothing but smallest unit which will store information about the color of the images and the intensity of the images. Generally, when we are watching some movie or something, some screen on the image, then we can think of image as the pixel per inch, and it means we can say that in 1 square inch how many pixels can come. So for 1 square inch, nearly minimum 300 pixels are required. So we are saying it as pixels per inch. If we have the 500 pixels per inch, then we are saying it is storing 500 pixels per inch. Now what is image processing? Image processing, whatever the operations we are applying on the images is considered as the image processing. For example, whenever we are capturing some image from the camera and we want to change the things into the images, like I want to change the color of the image, I want to change the contrast of the image, I want to change the brightness of the image. So all those operations are the part of the image processing. It means we can say that if we want to enhance some image, or for enhancing some image, whatever the operation we are applying is called as the image processing. Now digital image processing is the use of the digital computer to process digital image through an algorithm, or we can say whenever we are capturing the image by some device, generally the image is stored in the form of in the analog form. But what we want to do, we want to store this image into the computer system and we want to process that image. So for processing that image, we need to store that image into the digital form. So storing the image into the digital form is called as the digital image processing. So in the digital form, the image consists of two-dimensional array of pixels. Definition of the digital image processing: an image can be defined as the two-dimensional function fx, y, where fx, y is the function which generally the amplitude of the particular pixel, or we can say it will store the intensity of the particular pixel at the coordinate system x, y, where x, y is nothing but the spatial coordinate system, where so we can say that fx, y is representing the intensity of the pixel at location x, y. So now we'll come to the morphological image processing. The mathematics behind the morphology is it is used to extract image component that are useful in representation and description of region shape, such as boundary extraction, skeletons, convex hulls, morphological filtering, thinning, pruning. In these 6 terms, we knows the maximum terms. The convex hull is nothing but the boundary of the pixels. Means if we have the number of points and we want to draw the boundary, then this boundary is done by the convex hulls. thinning is nothing but the removing the extra part from the images, and pruning is removing the distorted portion by using the thinning. So in morphological image processing, generally we are enhancing the image by improving the damaged part of the image. So there are number of ways by which we can improve the image, or we can say we are improving the damaged image in terms of shape, in terms of boundary, in terms of distortion inside the image. So some mathematical operations are required for image processing. The basic set operations we already know about it. If we have two numbers a and b, how we are doing the union of a and b. In the same way we are doing the union of the images. So here we can say that we have two images a and b, some portion is common and some is not common. If I want to take the union, it is similar as the mathematics we have seen earlier. Similarly, a intersection b will contain the common part, a complement will contain the exclusion, a minus b is just like as mathematics. Now reflection and the translation are very important with respect to the image processing. Reflection is nothing but the mirror image reflection, we can say. So it is mathematically described by w is nothing but the minus b. Az is the translation. When we want to translate some image from some point to other point, then we need to add simply algebraically a to z. These are some more examples how the not operation or how the general operations are applied on the images. We can see here not operation, and operation, or exclusive, or not and. Now I will come to the structuring element. Structuring element is just like a mask. As we are applying the mask over the image, structuring element is also used in the morphology of the image. It means if we want to sharp the boundary of the image, or if we want to improve the distorted portion on the foreground of the image, then we are using the structuring element. So it means image morphology is maximum depending on the structuring element, what kind of structuring element we are selecting actually. So some set of props that image under study. For each structuring element define origo. Origo is nothing but the origin. The shape and the size must be adapted to geometric property of the object. There are two type of morphological operations basically, erosion and dilation. Erosion, as its name is suggesting, it means erasing of something, or we can say it will do the shrinking. Similarly, dilation will do the growing. Now combination of this erosion and dilation is called as the opening and closing. Okay, opening is generally working on the object, means foreground objects, or closing is working on the background objects. So here we'll discuss erosion in detail. Erosion, does the structuring element fit the set? Erosion of a set A by structuring element B. So here B is the structuring element, A is, we can say, that image, such that all Z in A, B is in A when origin of B equal to Z. So here it is the sign of the erosion. So for erosion we are using A minus B. So A minus B equal to Z. So if in detail we want to discuss about the erosion, then we can take some example. By this example it will be understood well. So here this is the image, this dark part is the image, here this is the structuring element. So if I want to apply the erosion operation, the concept is I will apply this structuring element over the image. It means I will try to overlap this structuring element with the image. If this element is completely matching with the image, then central pixel part will be highlighted and rest will be removed from the image. So here we can see that if I will apply this structuring element over here, we can say that it is completely matching, and if it is matching, then central pixel value will be highlighted. Similarly, whenever I am shifting it down, we can see that, then again I can highlight here, and when again I will shift it down, I can highlight it here. So wherever I will find there is a complete match with the structuring element, I will highlight the central pixel value. So here I am not able to, yes, okay, if I will match it here, then this pixel will be highlighted. Whenever I will shift it here, then this picture will be highlighted. Whenever I will shift it here, then this will be highlighted, and whenever I will shift it here, then this will be highlighted. So here we can say that the star portion is actually the highlighted portion of the image. So here one more example. In this example, we are taking the different kind of structuring element, the size or the style of the structuring element different. Whenever I will apply the structuring element for erosion, here I can see that here it is matching completely here. So the central pixel will be highlighted. When I will shift it down, this pixel will be highlighted, this pixel will be highlighted again. Whenever I'll shift it down, this pixel will be highlighted. Means at last here when I am here, then the central pixel will be highlighted. But if I will shift it further, then it will not completely match. That's why other picture cannot be highlighted. Similarly, here also this portion will be highlighted because it is a complete match. So here I can say that whenever there is a complete match, the central pixel value will be highlighted and rest will be removed. It means the meaning of erosion is that it will remove the rest element or rest pixels from the image. The objective of erosion is to sharpen the boundary of the image. You can say that sharpen the boundary of the foreground objects. Whenever for foreground objects the boundary is not clear, then the erosion operation will be applied to clear the boundary so that it can be clearly identified. So here I am showing some code so that we can understand how the things are working whenever we are applying this thing into some programming code. So by the use of the programming, we are using here the CV2 is nothing but the open CV. Similarly, the numpy as np, simple numpy library we are using here, and I'll read the image here by using the imRead operation. The name of the image is callballs.jpg, and I'll apply the threshold operation on the image by for converting image into the other image so that the morphological operation can be applied. So this thresholding operation will be decided by this value. Here we can see that the operation that is used in the thresholding is the thresholding binary inverse. Thresholding binary inverse is nothing but the thresholding operation where the value, whenever the value of the threshold, whenever the pixel value is increasing or increasing the value of the threshold, then the previous value will be highlighted and rest value will be ignored. Similarly, this kernel is nothing but the structuring element. It will create the structuring element for the image. 2x2 matrix it is creating for 2x2 of 1 means matrix of it is creating 2x2 and all values are 1. So this is the structuring element for this particular example. And now finally the erode operation is applied over this mask and the kernel. So here we can see that whenever the erode operation is applied over the mask and the kernel, the image will be the erosion operation will work. So here this will be image will be displayed by the imShow function. So here we can see that the value of this is the original image, this is the mask image, and this is the kernel. Kernel means the structuring element, and this is the result of the erosion. So next for dilation, similar this is for dilation. we'll study it in the next topic. So matplotlib function is used for the displaying or managing the number of images. Whenever we are having the number of images and we want to control the display part of the images, then we'll use this matplotlib function by using the subplot. So dilation function is just opposite to the erosion function. The objective of erosion function is to improve the boundary of the object. It means if say there is some disturbance in the boundary of foreground objects, then we'll apply the erosion operation. Dilation operation is just opposite to that. It will applied whenever there is a distortion in between the object. It means not on the boundary, in between the object some distortion is there, then we'll improve the object by applying the dilation operation. So this is the formula of the dilation operation. It is represented by plus operation. So as its name is suggesting, plus means it will increase or it will improve the distorted portion of the object. So now we can see how this dilation operation is performed. So the idea is that whenever we have the structuring element, we'll try to match this central pixel value with the image. If this wherever the central pixel value is matching, all other value will be automatically highlighted. So here we can see that whenever I will overlap this structuring element here, and here it was actually the image, so central pixel is matching. As soon as we'll find that central pixel is matching, we'll highlight all other values. So it was the idea behind the dilation. So in this way, if I will apply this dilation, this structuring element on this entire image, then this star part is showing the example of dilation. So here this is the example with the next structuring element. So we can see here that this plus kind of structuring element, when applied over the image, then the answer is like this. Now usefulness, as I told that erosion is used to sharpen the boundary of the foreground objects, and dilation is used to fill, basically filling the holes, filling the distorted portion of the object. So here removal of structure of certain shape and size given by the structuring element, and dilation filling of hole of certain shape and size given by the structuring element. So combining of erosion and the dilation. So there are different means benefits of different functions. Dilation have the benefit that it will fill the holes within the objects, and this erosion have the function facility that it will sharp the boundary object. So whenever I will combine all this, then the things will be better. It will means combination of structure dilation and erosion with use of the structuring element, the things will be better. So the opening operation is the combination of this erosion and the dilation. So important thing is that in the opening operation I will use this whole O. I will use this hollow O, A, O, B. The answer of A, O, B is A, where A is the image and B is the structuring element. So first of all, we need to apply the erosion operation by using the structuring element, and the result of this erosion operation, on the result of this erosion operation, the dilation operation will be applied by use of the structuring element B. So it will eliminate prosperous, breaking necks and smooth contours. So the opening operation we can discuss here. It is the image as we have done earlier also. In the opening operation, first we'll apply the erosion, then we'll apply the dilation. So whenever I will apply the erosion over this image, we have already seen that these parts will be highlighted in this way, and whenever I will apply the dilation with the same structuring element, these parts will be highlighted. We can see here that this is the result of the opening. Now we can use the different structuring element and we can apply this this over for the result of the opening. This is the result of the opening. Closing Closing operation is just opposite to the opening. In the closing operation, first we have to apply the dilation operation, then erosion. So the application of the closing are, it will smooth contour, fuse narrow breaks and long thin gulfs, eliminates small holes, fill gaps in the contours. So again, the operations of the closing, first we have to apply the dilation, then we'll apply the erosion operation. So here we can see that it is the previous image. Whenever we'll apply the dilation with this, the result was something like that. Whenever we'll apply the erosion with this, the final result is this one. Means first we have to apply dilation, then erosion. With the change of the structuring element, this is the final image. So whenever we'll use in the Python, the operation is morphology cv2 dot morphology ex, the mask that we have used for the image. cv2 dot morph is nothing but the application of the morphological image operation, and kernel is the structuring element. So here this basically morph underscore open is the opening operation, and morph underscore close is used for the closing operation in the programming language. The properties of the opening and closing is, opening is AOB is a subset of A. If C is a subset of D, then COB is a subset of DOB. If AOB OB equal to AOB. In the closing operation, A is a subset of A dot B. So here this is very important. This is denoted by the dot, whereas this is denoted by the hollow O. If C is a subset of D, then C dot B is a subset of D dot B. So generally these properties are coming in the objective type of questions. Duality principle. So duality principle, whenever we are applying the duality principle on the closing, it will convert it into the opening. So in the duality principle, we can see that opening and closing are dual with respect to combination of complementation and the reflection. Whenever we will apply the complement operation over the closing, A closing B, complement is equal to A complement opening B reflection. So this is the sign of the reflection. So here these are the examples. Some images are given to us. A is given to us, B is the structuring element, and whenever apply we'll apply the erosion operation, this will be like that, and the complement of this erosion is this one. This is A complement, and A complement B is equal to this one. So here it is actually the proof of the previous one. A dot B complement is equal to A complement hollow B. The application is filtering whenever we are using the thumb impression. So sometimes the edges are not very clear. So for doing the things very clear, the erosion and dilation operations will be applied over the images. Hit or miss transformation. It will find, locate one shape among the set of shapes. Template matching, composite structuring element object part of the B1 background. Here basically two structuring element B1 and B2 are used. So B1 fit the object while simultaneously B2 miss the object. That's why it is called as the hit or miss transformation. So boundary extraction. In the boundary extraction, as the formula is given, A minus A erosion B. So first of all, the objective of boundary is that I have to find the boundary of this particular image. So here we can see that these are the boundary objects. So my objective is to find this boundary. So whenever I want to find the boundary of the object, will apply this operation. A minus A is where A is the image and B is the structuring element. So here we can see that whenever we'll apply this structuring element over the image with the erosion operation. So again I will remind you that the meaning of erosion is whenever the structuring element is completely matching, then the value of the center pixel will be highlighted and rest will be the discarded. So here we can see that this is the erosion operation, and whenever I will complement, I will subtract this erosion from A, this will be the answer. This is the boundary extraction. So here we can see that the boundary will be highlighted in this way. So again the example of the boundary extraction, region filling. So as the formula is given here, xk is equal to xk minus 1 plus b, where xk starts with the x0 actually, x1 sorry, x1 equal to x0 dilation b. So here we can see that this x0 is nothing but the image itself, original image. Whenever I'll apply this original dilation of this original image with the structuring element, we'll get the x1. Simultaneously we have to use this a complement also. So here we can see that this x1 is can be found by the use of this dilation operation and this image, dilation operation of image and the structuring element. So here the erosion and dilation examples, again we can see here that this image is given and this is the structuring element. Whenever we want to apply the structuring element over the image, then we can see here. So for erosion I have to check whether this structuring element is completely matching or not. If it is not matching, then we have to remove all the ones. If it is matching, then only highlighted value will be kept. So here we can say that if I will keep it here, then it is not matching. Not matching means it will become 0. Here if I will apply it is not completely matching, it will become 0. It will become 0. So all will become 0 in this way. But whenever I'll apply this structuring element here for erosion operation, this is completely matching. It means we have to keep it like this. Similarly this one. So these are the very good example of erosion and the dilation. And again I will repeat the dilation. In dilation what we will do, we will try to match the central pixel value with the image. If it is matching, then all the values corresponding to the other elements will be highlighted. So here in this image we can see here that this value is matching with the central pixel, so all other images, all other points will be highlighted. So this is the result of the dilation. So this was one question, one numerical portion. So here one image is given, sequence of one image is given and structuring element 1 to 1 is given. We have to compute the dilation, erosion, opening and closing operation over this. So here we can see that whenever I want to find the value of the dilation, meaning of dilation means add and take max. So whenever I first of all I have to apply this structuring element by shifting this 1 to the left. Now I will add this 5 and 2, 7 and 1. So 5 and 2 is 7, 7 and 1 is 8. So I have to find the maximum one is 8, that's why in the answer I have 8. Similarly I'll shift it to the right and again I will find the addition of this 1 and 11 is 12, 7 and 2 is 9, 5 and 1 is 6. So 12 is the maximum one, that's why answer is this one. So this important, this numerical is very important from exam point of view. Next is the erosion. The formula of erosion is subtract and find minimum. So here we can see that whenever we are taking the subtraction of this structuring element with the image, the answer is 7 minus 1 is 6 and 5 minus 2 is 3. So the minimum one is 3. Okay. Next is opening and closing operation. For applying opening and closing operation, we will discuss in the next class. Okay, thank you all of you.